The substances, materials, and technologies in this video appear to defy the laws of physics. They exist despite those laws and amaze us simply by existing. At the same time, all of them are completely real. As usual, we've saved the most incredible ones for the very end. Let's start perhaps with europium metal, which in the periodic table of chemical elements belongs to the class of lanthanides. They all stand apart because they possess unusual properties. But even among them, europium looks like the strangest one. First of all, this element has anomalous chemical activity. If you put it in water, it will immediately dissolve. But europium doesn't want to burn at all. Strangely, it also behaves unusually when exposed to air. After a couple of days, it turns into an oxide powder, which takes on a red tint under ultraviolet light. Thanks to this, it is used in glowing powders, phosphors. Its particles are also added to luminescent paints. Euro banknotes have a rich red color, which is visible on your monitor screen. This is due to Europe. The next material with absolutely unique properties is pyrolytic graphite. It consists of many layers of graphene, a substance we discussed in detail in a previous episode. But pyrolytic graphite has completely different properties. It is a perfect diamagnet, meaning it is stronger than all other materials. It repels a magnet, no matter which pole is facing it. In front of you is a block of 9 magnets, arranged in a specific sequence, and above this block floats a plate made of pyrolytic graphite. Of course, the levitation effect is achieved if the graphite is not too heavy. But if you use a larger magnet, it will work even with a heavier piece of graphite. There is another unusual property of pyrolytic graphite. It is the best conductor of heat among all known materials. If you take a plate in your hand and try to cut a piece of ice with it, it will work. Under the influence of heat, the ice will rapidly begin to melt and break apart. These materials are hydrophobes, or hydrophobic substances. Look at this square of green liquid. Why does it keep its shape and not go beyond the invisible boundaries? The thing is, the surface around the square is treated with this very hydrophobic material. If a drop of water lands on it, it takes a perfect shape and just rolls down. This is the so-called Lotus effect. And recently, Russian scientists from the city of Dubna learned how to reproduce it on the surface of any material. They achieved this thanks to modern technology of colloidal synthesis of nanoparticles. Studies using an atomic force microscope showed that this hydrophobic nanorelief almost completely matches the surface of lotus leaves, which in nature repels water that lands on it. And another group of scientists from the University of Rochester managed to create a hydrophobic material of such quality that water droplets simply bounce off its surface. The unique feature of this method is that the water-repellent properties are given to the material not by additional treatment, but by the very texture of its surface. This means that its effect won't end after a certain period of time. The areas of application for this material are limitless. Who knows? Maybe in a few decades we'll have these kinds of multi-level pools. Although that's a bit of a different story. We'll discuss that possibility later. For now, let's examine water again, specifically dry water. The name itself might blow your mind, but the properties of this substance are even more unusual. In the 1990s, dry water was invented by specialists from a company, and today it exists under a trademark. Scientists took the formula of ethyl isopropyl ketone and replaced all 12 hydrogen atoms in it with fluorine atoms. As a result, they obtained a substance unlike anything people had encountered before. Today, there are several variations of this substance with different temperatures and densities. The most well-known are Novec 649 and Novec 1230, which have a very high density, making their weight significantly greater than that of regular water. Other unusual properties of this liquid include its weak ability to wet fabric and any other fiber. Look what happens if you dip a napkin into regular water and into dry water. In dry water, it hardly gets wet at all, and the remaining water just rolls right off it. Dry water also has a low dissolving ability. That's where the name dry water comes from. It is also used in automatic fire extinguishing systems. Next on our list of unusual substances is hot ice. Basically, it's a liquid that becomes solid with the slightest impact on it. Hot ice, or sodium acetate, turns from a liquid to a solid with just a single touch, like crystal ice. The same patterns form on the entire surface, as you see on windows in winter during frosty weather. When you press it, a crystallization center forms, from which information about the new state is passed along the chain to the molecules. Of course, this substance only looks like ice. To the touch, it is quite warm and is actually used to make chemical heating pads. Number 6 on our list is one-way bulletproof glass. Regular bulletproof glass has been known for a long time. Its main principle is to stop bullets and absorb the shock wave. But such bulletproof glass is useless in combat situations when you need not only to defend yourself, but also to attack the enemy. When attacking, the glass does not let bullets through from either side. However, a group of scientists from the PAS company managed to solve this problem. The one-way bulletproof glass they developed allows bullets to pass through from one side, but stops them from the other side. This is done by coating the glass with special acrylics. The key is not to confuse the correct side at the crucial moment. And now, here is a gas that can hold solid objects. This is hexathion sulfur. If you fill a closed container with it, it will settle at the bottom because it is heavier than air. And if you place a small object on top, for example, a little boat made of foil, it will easily hold it on its surface. But if you remove the gas, the boat will sink to the bottom. Another property of this gas is its ability to lower the frequency of any sound that passes through it. And if you inhale a little sulfur hexafluoride, you'll sound like Darth Vader. In 8th place in our ranking, the Celtic stone, an object that intrigued our distant ancestors, was known to ancient Germanic tribes and Celts, hence its name. Today, archaeologists discover Celtic stones in various parts of the world. This is a toy in the shape of an ellipse, which is designed in such a way that it can rotate around its axis only in one direction. In the opposite direction, the Celtic stone simply doesn't want to spin at all. This thing violates a number of physical laws, such as the law of conservation of angular momentum. The main secret of the Celtic stone lies in the fact that the direction of its geometric axes and symmetry does not coincide with the direction of the axes of inertia, which pass through the center of mass. And now imagine that matter itself begins to take on any shapes you want. We are familiar with 3D printing, where a printer produces precisely what we need based on specified parameters. Printing allows us to create objects that can change their shape or structure on their own, under the influence of water, high temperature, light, or other factors. What will happen to a thin strip of wood if you wet it with water on one side? It will start to deform, but these deformations are unpredictable. Researchers at the Massachusetts University Scientific Lab have discovered how to predict and program material deformation. It turns out to be programmable matter. Scientists give wood the desired shape by wetting the material in strictly defined places. And look at what happens. But researchers are working not only with wood. A whole range of different programmable materials has already been developed. And now we present to your attention Gömböc. Looking at this plastic figurine, you would never guess what unique properties it has. But its unusual shape and composition are the result of solving a unique mathematical problem. Scientists previously thought creating an object with such a shape was impossible. We all know the roly-poly toy, which always returns to its original position. This is achieved by placing a weight at the bottom, while the top is hollow. Gabor Domokos and Peter Varkonyi, two Hungarian scientists, decided to investigate whether creating a homogeneous object with this property is feasible. They succeeded. The Gömböc is the first 3D convex body with one stable and one unstable equilibrium point, known as a monostatic object. It can rest in only one equilibrium position. If you turn it over, tilt it, or place it on another side, it will always return to its original position. Initially, the existence of such an object was proven theoretically by solving an extremely complex mathematical equation. It took 10 years and a huge number of experiments to solve it. The creators received numerous awards for solving this problem and for the pepalats. Now, a few bonuses. In the previous episode, there was a mention of supercooled rubidium, which is not a joke. Researchers managed to get rubidium atoms to behave like a substance with negative effective mass. This means that under external influence, these atoms did not move in the direction of the force vector. Under the experimental conditions, they behaved as if they were hitting an invisible wall every time they approached the boundaries of a region with a very small volume. The corresponding article was published in Otricetel Noi. The concept of effective mass is used by scientists to describe the behavior of holes in semiconductors, which are found in modern electronics used by everyone. We have 2 great episodes about these holes and electricity. We suggest watching them. In general, since rubidium atoms were moving in the direction opposite to the vector of the force applied to them, all over the world, the media announced the creation of matter with negative mass, leaving out the word effective. Imagine 2 masses placed next to each other. The negative mass is attracted to the positive one, while the positive mass is repelled by the negative one. Therefore, both masses will experience equal acceleration forces, which violates Newton's third law. After all, such a system of 2 masses would accelerate endlessly. Does this just seem like a silly thought experiment? But in fact, scientists really love such paradoxes. Not long ago, an article titled "There Are No Laws of Physics" was published in the scientific journal Quanta. Its author is Robert Dickie Graff, director of the Institute for Advanced Study, where Einstein spent 22 years of his life. Dr. Dickie Graff writes about a frighteningly branching labyrinth of possibilities, an almost infinite network with weak interconnections, consisting of alternative versions of reality. Dr. Dickie Graff writes, "If our world is just one of many, what should we do with the others?" The view of modern physics on the universe is the complete opposite of Einstein's idea of a single cosmos. In his article, Robert Dickie Graff writes about string theory. The result of this theory was a labyrinth of mathematical solutions numbering 10 to the 500th power, where each solution corresponds to one of the potential universes. One of these is ours, but that's not certain. But why did scientists need such mathematical twists? The discovery of dark energy, a mysterious force accelerating the universe's expansion, causing galaxies to move apart at increasing speeds. Dark energy has all the characteristics of the cosmological constant, which Einstein introduced into his equation of the theory of relativity a century ago, but later abandoned. However, the experimental value of this cosmological constant differs from the theoretical one by a factor of 10 to the 60th power. We will talk about dark energy in future episodes, so let me know with likes and comments if you're interested. But for now, think about this. Maybe the point of view isn't so far from the truth that Einstein is not the greatest scientist of all time and nations, but rather a person who set fundamental science back by a century. If it weren't for him, we would now be observing something like this. It sounds too heretical to believe. Like this video if you've ever thought about something like that. Well, if you haven't thought about it yet, you can find some food for thought in these episodes. Well, that's all for today. Thank you for your interest in the topic and your thoughtful comments. See you on Cremola.